Hey friends, me again. So, sorry that I'm all bundled up. I know it's hot outside, but it's currently 10:12 and my family's asleep and this is the time I have to do this, so it's on nighttime temperature in my house. So, yeah, I'm a little cold. So I put on my husband's jacket, his Notre Dame jacket, cause I don't know, he's special. He likes Notre Dame. We fight over the controls on Saturdays during college football season. I'm a dog fan. So, anyway, that is neither here nor there. It's time to go over the study guide. So, let's get started. I just went by her headings on the study guide with whatever slideshow you need to reference, and some of these I will have slide numbers for you to reference. So, just know that I will give you the slideshow that I'm on at the start of each section. So, okay, let's see. Top of the study guide, exam 3, page 1, prokaryotic classification. So, it's the prokaryotic classification slideshow. Cellular microbes. So, cellular microbes are made of living or once living cells. That's what makes them cellular. Versus acellular microbes, which are made of organic molecules, so like proteins, fats, lipids, all that fun stuff. And they contain no cellular or living material in the final product. So cellular microbes are living or once living. Acellular, not so much. It's just made up of organic components. So, okay, examples of cellular microbes are bacteria, archaea, fungi, protists. They can be unicellular, they can be multicellular. It's everything that you could possibly think of, pretty much, that is living or was once living in microbe. Now, acellular microbes covers viruses. So, it's always been a hot button debate as to whether viruses are living or not. So they get classified as not living. So, viruses and other infectious agents, such as prions and viroids, those are acellular. Those are examples of acellular microbes. And those are the ones that are made up of non-living components, or were never living components. They are made up of organic molecules. So, okay. Carl Woese classified, I really don't know if I'm saying that right or not. He classified the 3 domains based on eukaryotes sharing a common ancestor that excluded bacteria. So it splits the archaea and the bacteria. The difference in the 16S ribosomal rRNA, so the rRNA structure, and the membrane lipid structure and the sensitivity to antibiotics. So basically, instead of the archaea and the bacteria staying together in the tree and then breaking off, it breaks off into 3 instead of 2. So he based it on the fact that they all had a common ancestor, but the archaea went one way, the bacteria went one way, and the eukaryote went the other way. So the 3 domains are archaea, bacteria, and eukaryote. So archaea and bacteria are different. This is where his classification system comes in, because it's not archaebacteria and eukaryote, it's archaea, bacteria, eukaryote. Solid sound? Okay, so it's just saying that these 3 had a common ancestor, and then they split off one way, and one way. Y'all pay no attention to my chip nail polish. Let's see. Know the following. Acetophiles. So, if you are philic, think about hydrophilic likes water. Break the word down. Phobic means you're afraid, right? So you don't like whatever that is. So philic is the opposite. Philic means you like that. You thrive in that. So acetophiles are going to be the extremes that flourish in a high acidic or low pH environment. So if it's highly acidic, it's low on the pH scale, right? Go with that. So the lower the pH, the more acidic something is. So acidophiles love acid, so it's going to love that lower pH. Halophiles love salt, so high salt concentrations. Thermophiles are going to like high temperatures. Psychrophiles, I think you're psycho if you like the cold. Actually, I like the cold, so I'm a little psycho. I also run very hot. So, psychrophiles, that's what it looks like to me. Psychrophiles, cold loving. So, now you won't forget it, right? Methanogens, they produce methane gas in ruminants and in humans. So, if you think of anything that makes methane gas, it's a methanogen. Okay? So, okay. Slide number 5, the types of interactions amongst organisms. So this is where you get your mutualism, your amenalism, your commensalism, your neutralism, and your parasitism. So there's 5. So mutual, it is to mine and yours mutual benefit to have a good relationship because you do well on your tests and I like helping you do well on your tests. So we both benefit from this relationship, right? It is to our mutual benefit that we get along. Because the more we get along, the more fun we have in class. The more fun we have in class, the more you learn. It's a win-win for both parties. So mutualism, both A and B get a benefit. Amensalism, A is harmed and B is unaffected. So, telephone pole, car. Which is harmed and which is unaffected. So, A, the car, is harmed, but B, the telephone pole, it's not going to do much to it, right? Commensalism is where A benefits instead of is unharmed, and B is just unaffected. So, what's a good example of this? Something benefits while the other stays unaffected. That's a good thing for you to look up. Look up a good commensalism relationship in nature and micro and whatever you want to look it up. So neutralism is where they both just get along. Nobody benefits, but nobody gets harmed either. So they're both just neutral. They're both Switzerland. They're both neutral. Okay, parasitism is the 5th, where A benefits, they get all the good stuff, and B is like, what you doing to me? I'm gonna shrivel up. So parasitism is where A takes from B and B is harmed. So mutualism, A and B both benefit. Amensalism, A is harmed but B is unaffected. So remember the car crash, telephone pole? A, the car gets harmed, but B is just like, meh, just still chilling. I'm still gonna be a telephone pole. I'm still gonna get you your phone calls. Commensalism, A, hey, thanks for all your help. B, you're welcome. You didn't give anything back to me, but you didn't take anything from me either, so I'm just chilling. Neutralism, they're both Switzerland. They're neutral. They both just get what they get and take what they take, and nobody's benefited and nobody's harmed. They're just there. And then parasitism, parasites. Think about a tapeworm. The tapeworm gets all the benefit, and then the person is like, dying, can't stay out of the bathroom, has to go puke, has to go poop, is losing all the weight, hurts all the time. So yeah, that's a parasitism. All right, so Now let's look at what's next. Slide 13, the domain archaea. So it is recognized as a coherent group by WOS. It is prokaryotic, so single cells with no nucleus or membrane-bound organelles. So that's the difference between a prokaryote and a eukaryote. Eukaryotes have nuclei in their cells. They have membrane-bound organelles. They're typically the higher order. Prokaryotes, they are single-celled. They have no nucleus, nor do they have any membrane-bound organelles. It's just kind of free floating in there. They have no peptidoglycan in the cell walls. They have S layers. They are asexual, so they reproduce by binary fission or budding. None of them really are known to make spores, so they just kind of like split themselves. And they are detected in nearly all environments. So it's not like they're rare. Okay, let's see. I got 17 pages of notes, y'all. 17. All right. Now, I grant you, I write big and I leave a lot of space sometimes. So, it may really be about 12. All right. So, next we're looking at slide 16. So, domain bacteria, or the classification of bacteria, not domain bacteria. Classification of bacteria. So, classification is broken down into bacteria is broken down into two classifications. And we've already talked about this in lab. One is positive and one is negative, right? Now, positive has the thin peptidoglycan, right? Negative has the thick. The thick. Thick. Like Austin Riley. For those of you who don't watch baseball, you're not going to get that, but for those of you who do, you'll understand. So negative is broken down even further. There's a lot more gram-negative bacteria than there are gram-positive. You've got the phylum Proteobacteria, Cyanobacteria, Chlorobi, Chloroflexi, Chlamydiae, Plantomycetes, I can't read my own handwriting. Bacteroidetes, Fusobacteria, Spirochetes, and Deinococcus thermus. There's a lot of these. This is all on slide 13. Or not 13, 16. I looked at that wrong. And that's all the gram negatives. So in gram positive, you got the Firmicutes, the Tenericates, and the Actinobacteria. And those are the positives. There's just 3 phylum in that. Or phyla. I'm sorry. 3 phyla in that. And again, that's all on slide 16. So if you feel like you need that in front of your face, then slide 16 on the prokaryotic classification slideshow. All right, slide 26. Know the difference between endemic, epidemic, sporadic, and pandemic. So, somewhat appropriate given the times that we live in. All right. An endemic is consistently present but limited to a particular region. It's predictable. The spread is predictable in something like this. So consistently present. It's almost always there, but it's regional. It's going to just be in really the 1 or 2 spots that it's found. Sporadic is exactly how it sounds. So it occurs at irregular intervals and only in a few places. The occurrences and spreading is scattered and isolated. So sporadic is just as it sounds. It's sporadic. An epidemic is an unexpected increase in the number of cases in a specific geographical region. So an epidemic would be if we had an influx of chickenpox in Northwest Georgia. There's a chickenpox epidemic in North Georgia because all of these people are suddenly having this go on. Whereas like an endemic, like we said, it's consistently present, but it's always in the one spot. Say seasonal allergies in the South, because God knows we have enough pollen to coat a house multiple times over on one day. So people are consistently going to have allergies, but the types of allergies people have are endemic to or specific to the region that they're in, because we have things that grow here and bloom here and make us here that people in New York or Ohio or Oregon don't have. Whereas sporadic is like you have a random chicken pox here and then a random chicken pox in Kentucky and then a random chicken pox in Utah. So like it's just like what? Like, kind of random and all over the place. All right. Pandemic. Y'all should know this one. We should know this. A pandemic is when when things spread rapidly across several countries, continents, all across the world, and the disease growth is exponential. So, do I really need to give you an example? Or you think you got that one? I think you got it. Smart guys and gals. Okay. Next, we're looking at slides 21, 22, and 24. So, alpha proteobacteria. It's important to the environment and to agriculture. It forms root nodules. So, it forms in roots of legumes with rhizobia, or it's the site of nitrogen fixation. It's super important in agriculture because that nitrogen fixation is super important. It can cause crown gall disease, and it can be used in the genetic transformation of plants. So, like, it can be used to transfer plant genetics around. So, like, if you want to make your own plant, you can use this, and it will help transfer those genes over. There are human pathogens that can be dangerous to us or inhaled by us. See slide 24 for which bacteria causes which disease. If you feel like that's something you think she's going to ask. Y'all know how she asks questions? I don't. I'm just answering the questions that are in front of me. Peppermint tea, y'all. Perfect little nighttime treat right before bed. No calories. Soothes your throat. And tastes like peppermint. And then I can just go brush my teeth and taste more peppermint. So anyway, slide 24. Pathogens for the alpha proteobacteria and how it affects humans. Okie smoky. Next we have beta proteobacteria. And these are going to be fun to say. Y'all, my accent makes me butcher things a lot. I love that y'all just go with it when it happens in class. Thank you. I really appreciate that. There's that mutual respect we got going on. Okay. Beta proteobacteria. So we're looking at slides 28 and 29. They are broken into, let's see, Burkholderia. Sounds good to me. It's rod-shaped and it's gram-negative. Let's see. It uses flagella, so it moves. It can grow in disinfectant solutions. Isn't that lovely? And can cause big respiratory problems. So, lovely, right? Those bacteria that are resistant to those disinfectants. Yeah, looking at you, staff. Okay, next we have Bordetella pertussis. This one I know. It's a coccobacillus, so it's non-modal. It's gram-negative. It's aerobic and fastidious, and it produces several toxins that paralyze movement of cilia in the respiratory tract and directly damage the cells. It is the cause of whooping cough. Pertussis. That's whooping cough. Just always know that. Bordetella pertussis. Just pertussis needs to be synonymous with whooping cough in your brain, in your mental dictionary, encyclopedia of knowledge that you got going on. Pertussis, whooping cough. And so what that bacteria does is it releases toxins in your airway, and it freezes up the cilia, so those little hair-like structures in your respiratory tract. It freezes them up, and you can't breathe, and so you're coughing, and the more you cough, the worse it gets, and it's just bad. It's bad. So there is, excuse me, side note, fun fact, when you're pregnant, they give you a shot for this so that you don't, if you're exposed, you don't pass them along to your baby when they're born. And you have to wait until you're, I want to say after 30 weeks, you have to get it. But you only have to get it once if your pregnancies are close enough together, like this one here. Because, my pregnancies were only 8 months apart. Nathan was 8 months old when I found out I was pregnant with Laura. So, I only had to get the one shot, and it was still good for when I was pregnant with Laura. But they do offer that inoculation for you, which is kind of cool. Let's see. Next we have Neisseria. It is gram-negative aerobic and inhabits mucous membranes in mammals. So anywhere you think you have a mucous membrane, so your nose, but ladies, Joey, cover your ears. Another mucous membrane that you have, your vaginal canal. So this Neisseria gonorrhoeae, is what causes gonorrhea. Yeah, that one. And then you've got Neisseria meningitis, which causes the meningococcal meningitis. So the bacterial meningitis is what this causes. So it is fastidious. And so I've said that twice now, and you're thinking, Allie, what is that? It just means it's very difficult to culture. So sometimes it's hard to pin down what's wrong with you. It requires high levels of moisture, nutrient supplements, and carbon dioxide. It's microaerophilic, so that means it doesn't need a whole lot of oxygen to be okay. It grows the best in chocolate agar. It's optimal for its growth and for identification purposes. Chocolate agar. Who knew? Its growth is diplococcal. So, diplo, 2. Sorry, I had to put my T down. 2. So, cockle means circle. 2 circles, right? So, its growth is diplococcal, so it's got 2 circles. It's a pair of cells that look like coffee beans. So, chocolate and coffee for gonorrhea and meningitis. So, you'll never look at any of this the same again. So, that is it for beta proteobacteria. So, the pertussis, the Burkholderia, Halderia? I can't read my own handwriting, y'all. It's bad. And I'm not pulling the slideshows back up. Then you've got the Neisseria gonorrhea and the Neisseria meningitis. So those are the ones for the beta proteobacteria. Next, we're on to gamma proteobacteria. The Pseudomonas aeruginosa. So what we're looking at are slides 32 through 37. So just straight through those 6 slides, 32 through 37. So the Pseudomonas, it makes blue-green pigment and it infects wounds, causes UTIs, infects the urinary tract. It burns, it causes sepsis, abscesses, meningitis. Y'all, that meningitis is scary stuff. It really is. You've also got with gamma proteobacteria, you've got the Legionellas. It's all weird. So in those you've got Coxiella, so that is Q fever, and it comes from contaminated milk. So Coxiella, contaminated milk, Q fever. So the one with the X goes with the Q. Weird letters stick together. Coxiella, Q fever, is in contaminated milk. Next, you have the Legionella. So it's found in streams, warm water supply lines in hospitals, cooling towers of air conditioning systems. So Legionella pneumophilia is called Legionnaire's disease. I don't know if any of y'all have ever heard of that. So it's an aquatic bacterium, and it usually will make a lot of people sick at one time because of where it's found. So it's found, where did we talk about? Water supply lines in hospitals and cooling towers of air conditioning vents. So if the supply line is contaminated, anybody in the hospital that gets water from that supply line is going to be affected. The cooling towers from the AC, if it's an AC unit that runs an apartment building or whatever, everybody in said building is going to be affected. It is not good. Okay. Vibrio, however you want to say it. We're still on gamma. We've got a couple more pages. Well, a whole page and a half, another one on the gamma proteobacteria. It's long. It's a lot of slides. And I tried to streamline it. I really did. So the Vibrio, they're rods. There's a slight curve. They are found in seawater, so salt's important to them. They're motile. They use flagella. They may produce a toxin that causes hypersecretion of water and electrolytes in the GI tract. So, and can really jack up some wounds. So some of them can cause some serious wound infections. So you could have some super hyper water secretion in your GI tract, or you could have a very badly infected wound. One of them is Vibrio cholerae, which is the cause of cholera, which is profuse watery diarrhea. Just bad. If anybody's ever had a colonoscopy, it's on par with that. If you haven't, God bless you, good for you. You're all very young. Hopefully you have not had to have one. You don't want to know. It's bad. Next we have Vibrio parahemolyticus. It's usually in coastal salty water. It's less severe gastroenteritis. And you get it by eating raw or undercooked shellfish that was contaminated by the salty water on the coast. I like that salty coastal water, or salty coastal water. I lived in Savannah for 3 years. Let's see. Next we have enterobacterials. They're facultatively anaerobic. So, facultative anaerobes. Sorry, y'all. I just moved my knee and my computer rode up and down with it. They're gram-negative rod shaped. They're often sorry, my brain just turned off for a second. They're often enteric, so they inhabit intestinal tracts of humans and other animals, and they mostly ferment glucose. So they are fermenters of glucose, which is good. They have fimbriae, which help adhere to surfaces and mucous membranes, so their fimbriae help them just latch on. They produce bacteriocins, so they're proteins, bacteriocins. Proteins that lyse closely related bacteria. So the proteins help maintain ecological balance of various enterics in the intestine. So if these enterobacteria are in the intestine and something gets too close, they can produce a bacteriocin that cuts it off so that the balance stays. There's balance within the force, Luke. Because nothing too bad, nothing too good. You want that sweet spot right in the middle so that your gut doesn't get all off. Hence, probiotics when you take antibiotics. Just a little life lesson there. If antibiotics tear your stomach up, then take a probiotic when you take your antibiotic, and it should help you keep that gut level. Okay, next. Sorry. Next, we have enterotoxins. So they're cytotoxic and kill cells by altering the apical membrane permeability of mucosal epithelial cells of the intestinal wall. So enterotoxins are cytotoxic. So they kill cells by taking that apical membrane and jacking the permeability of those epithelial cells, those mucosal cells of the intestinal wall, where you need things to be reabsorbed. These enterotoxins can jack with that. It's not good. They're mostly pore-forming toxins, so chloride pores mostly, and they assemble to form pores in cell membranes. So these enterotoxins will go into the cell membrane, create these spores, and then cause cell death by the lysis of the cell. All right, next we have sugar toxins. Sugar toxins are the most potent bacterial toxins that have been identified. So there you go. Good for you. Mama would be proud. All right, they target ribosomes. And ribosomes is where protein synthesis happens. So they target those ribosomes and they stop protein synthesis. Causes cell death pretty quick. And hemorrhagic colitis. So it's inflammation of the intestinal tract and just absolutely bloody diarrhea. Most severe, you're going to get hemolytic uremic syndrome. And so you're thinking, okay, what's that? Hemolytic uremic syndrome is you have a very low red blood cell count. Hemolytic. Uremic syndrome. So you got low red blood cells, a low platelet count, and you're in acute renal failure, so kidney failure. Big time, bad time, not good times. So sugar toxins. They sugar. All right. We're still on gamma. Bacillary dysentery. Anybody ever played Oregon Trail? Y'all are probably all too young for that. But if you had the pleasure of playing Oregon Trail, you probably died of dysentery at least one time while you were on the trail. And when I was a kid, I didn't know what dysentery meant. I learned. I pooped myself to death. So, bacillary dysentery. Diarrhea. You got the diarrhea, you got the runs. It is contagious, and it is diarrhea with blood and mucus. It's not good. It's not good. It is Shigella. It is Salmonella. It is Campylobacter, E. coli. E. coli is already in your GI tract. It's one of those bacteria that you have a commensal relationship with, or a mutual relationship with, where it's really actually more commensal, where we're okay and we don't care because nothing is going bad, nothing's necessarily going good either, we're just normal, but the E. coli get to flourish. But if there's too much of it, then it becomes more parasitic because we start hurting and it's not hurting. So, Salmonella is in the GI tract of many animals. It is potentially pathogenic. See slide number 35 for the different types. There was a lot of them. E. coli is the same way. It lives in GI tract of us and animals. I'm sorry, it's not commensal, it's mutualistic. Apparently we get some good from that, so. See slide 36 for more details on E. coli. Next we have amoebic dysentery. So we're just having some really hard times right now with all this dysentery. Amoebic dysentery. Dysentery caused by an amoeba infection. So contaminated food, if the food's contaminated with the amoebas, you're going to get diarrhea. Entamoeba histolytica is the main cause. Balantidium coli is another cause, but the Entamoeba histolytica is the main one. Let's see. I have in my notes that you need to see slide 37 and make flashcards of those. So let me just pull that up and see what it is real quick. Because I said that, but I just want to make sure. Okay. Slide 37. Yeah, so it was on here that you needed to know. And there are, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 of them on here. So make a flashcard because it's just a little easy little sentence, if even a sentence that she's put with each one. I'll just go over them real quick since I have it right in front of me, but I'm not going to get into it. Let's see. Klebsiella, it's in soil and water, and it's capable of nitrogen fixation. Klebsiella pneumoniae can cause serious forms of pneumonia in humans. If there's ever that pneumonia name, then just go ahead and assume that it's going to be a pneumonia type. Serratia marquescens produces red pigment and can cause urinary and respiratory infection in hospitals. So it sounds kind of like it's opportunistic. Proteus, it grows on agar on swarming type growth, implicated in many infections of urinary tracts and wounds. Yersinia pestis, Black Plague, Black Death of medieval Europe, the plague, why pestis? Fleas on rats and dirty, and yeah, not good. Arwinia, it causes soft rot disease in plants. There's more about that one than the rest of them. Enterobacter is found in humans, animals, water, sewage, and soil, and can cause urinary tract infections and healthcare associated infections. And then you have Chronobacter, and it can cause meningitis and necrotizing enterocolitis in infants. Ugh. Associated with contaminated infant formulas. Eesh. Be right back. I have a crying child.